Hey robot makers, how you doing? Hope you're having a good day so far. So do you want to know how to set up a Jetson Nano to detect custom objects and see those objects detected in real time? Then this is the show for you. So let's dive straight in. Come with me as we learn to build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let me get over to my keynote and we can... Richard says, every day is Christmas for Kevin. I just get a lot of stuff. So yes, I was playing with this little M5 stamp before. We'll take a look at that towards the end of the show, along with some other things I've got to show you too. But this is all about object detection, so let's take a look at this, shall we? Okay, so this session is all about how to train our neural network to detect custom objects. We have done something similar like this before on a Raspberry Pi, but this is considerably quicker, like light years quicker. So we're going to look at types of computer vision. We are going to look at something called MobileNet SSD and what that stands for. We're going to look at how we prepare a model, so capturing the assets, the images, labeling those images up, training the model, and then converting it to something called ONNX, and we'll have a look at what that is as well. And then finally we'll use the model and do a bit of a demo as well. It's so cool. Can't wait to show you this. So this is what we're shooting for. We want to be able to detect and identify and localize different types of robots in a live video scene. So in that little demo I've got a snapshot of there. You can see it's detected an auto DIY in the scene, and it's also detected a SMARS robot in the scene as well. So you can just see over my shoulder here, this is where I've been doing that image capture. And if I go to my overhead camera, you can see that this little camera that's on this arm here, that is actually plugged directly into the Jetson Nano. So I'm just going to swap out actually my other camera to the Jetson Nano, so we've got that ready to go. And you can see there that that's pointing at the scene. I've used a white background just so that it's not cluttered and it's not getting confused with other bits and bobs, and it gets quite a clean capture of that image. So that's kind of what we're shooting for, and I've decided to capture 4 different types of robot. Ultimately, I'd like to be able to detect lots of different types. So maybe an in-move head, maybe, I don't know what else did I have on there, the weatherbot, the robot cat, the open cat. There's lots of different robots we could get it to capture, but 4 was enough, and I'll explain why 4 was enough shortly. Okay, so computer vision models. So there's 3 things that go on with computer vision. There is classification, detection, and segmentation. So segmentation provides an exact outline around the shape of an image, pixel by pixel, so it tells you exactly where that is. So imagine you're driving down a street and you want to get a person, and not just a rectangle around a person, you want to know the exact boundary of them, or maybe it's an office space and you want to know where the floor is, where the walls are, and where furniture is. That pixel by pixel will be really important to know which segment that falls into. We're not interested in that in what we're doing today. So classification identifies what is in an image. So we will be using that today. We'll be definitely detecting which type of robot that we have. And then detection places a bounding box around specific objects in a scene. So there might be more than one. So in that little segment I've got there, you can see that there's a house and there's a tree and there's some coordinates as well. Just made those coordinates up. But that's what detection does. So detection, it is also broken down into a few different steps. So detection is a branch of computer vision which deals with localization and identification of objects. So this localization and identification are 2 different steps, and when we put them together we achieve that goal of object detection. So localization is specifically about locating the object within that image or video stream, and identification deals with assigning the object a specific class or label. So those are 2 separate things, and what we're going to be using, the MobileNet SSD, can do a lot of those things very, very quickly together because it's optimized for that use case. So preparing our model, let's have a look at what we need to do here. So this will take some time. This took me all Saturday to do. So first of all, we need to create a label file. So we literally create a text file, and each line on the file will have a different class or thing that we want to detect, something that we want to give a label to. So I chose to have a SMARS robot, a quad SMARS robot, a SMARS mini, and an auto DIY, just for a bit of variation. So we want to create that file. We want to collect a load of images, and by a load of images, we're shooting for about 1,000 images of each class. So that's about 4,000 images ideally to get this neural network. So it's really chef kiss, you know, the best it can be. We then need to label the objects with the images to produce an annotation file, and we can use a tool to do that. And in fact, Nvidia have merged those first two steps together. So as you're capturing the image, you can actually label it too, just to try and speed up the whole process, because it does take a long time to do. Once we've got all those, we then need to train our model using this MobileNet SSD, and then we need to convert the output of that into something which is this Opal Neural Network Exchange, ONNX model format. And you can actually use this on different devices once you've created it. So, for example, you could create a lot of this stuff, train it on your Jetson Nano, and then move it to a Raspberry Pi, and it should work just as well. It's a format that's open from all of them. So Pascal VOC. So there is a particular format that we need for these storing these files and creating them, and a lot of the tools are based around this Pascal Visual Object Class format. So it's just a bunch of folders. Within those folders, it expects them to have certain file names, certain folder names, and then the files that are in there. So for example, in the images, you can have a whole bunch of images, and then you have a corresponding XML file for each image, and those XML files in the annotation thing are created by your labeling tool. And it simply just says what the file is, what objects it can detect within there, and what the coordinates are for each of them. Because what our neural network will do is it will just pull out each of those images, resize them, grayscale them, and then shove them through the neural network. We can have a look at that in a couple of minutes' time. So creating the labels file is dead easy. It's just creating a text file. So like I said, I've got SMARS, Quad SMARS, Auto DIY, and SMARS Mini. And you can see on that screenshot there, it's detected all 4 types there. And I just put that little red bubble just above it so you can see a bit clearer, because sometimes that text is a little bit small. You also get the percentage of confidence that it's detected this correctly. So you can see there the SMARS, the Quad SMARS, it's 99.5. It's very, very confident about that. The Auto DIY, 92.1, and that's probably because I didn't take as many pictures of that as I did with the others. SMARS Mini, it's detected 85.7 down there. That's because it's physically smaller, it's got less pixels to play with. And then over here, we've actually got an overlap, so it's detected SMARS twice, one with 96.4, the other with 89.6. And that's probably because it's 2 types of SMARS that it can detect. It can detect one with the matrix display or the one with the rangefinder on there. But I think also there's a bit of a bug in this detect net where it can overlap them, and it's to do with the threshold. So I've yet to fix that one. So asset capture. So this is a small video of me capturing some images. So you literally just draw a rectangle around the robot. You just move it in the scene. Then go back, draw the rectangle around it. Then you go up to the top right, you say what kind of object it is. So this one's a SMARS robot. You unfreeze the frame. You then move the object again. You then go back, draw another rectangle. It's like stop motion animation. So you can see here, this is kind of the amount of effort that it takes to produce a reasonable model. You need a lot of images. And ideally, not just from one angle, you want them from above, underneath, different lighting conditions with different backgrounds, overlapping other objects, and so on. So the more effort you put into this, the better model you will end up with. But I knew that I only had so much time to do this and allow for an amount of time where it doesn't work. I need to troubleshoot stuff. So yeah, you need to repeat this about 1,000 times for each object class that you're shooting for. So on that piece of software I'm using there is part of this Nvidia Jetson Inference GitHub library, which we'll have a look at. This is called the camera capture utility. So it enables you to sort of do that image capture, freeze the frame, draw the rectangle, and classify it. Okay. So Hypotic says using different backgrounds also helps. Yeah, so it can figure out what's just noise and get rid of that, whereas I've gone for that white background. Probably not the best thing, but it just made for a more pleasing video to record on. So training and testing, so the process flow for this. So I've taken this slide from a previous video that I did, which was on the object detection using a Raspberry Pi and using the InMove head as the camera. So if you want to look at that, I will put a link into the description on the video. I've not done that yet, but by the time you watch this, I will do that. So we need to load the data into the data model. We need to fit the training model with the training data set, and you do normally separate out your training data, your test data, and your your validation data have like 3 different sets, and 2 of the sets it might have seen before, but the 3rd set it will have never seen, and that's how you can see if it's actually detecting things. So what I've actually done here is I've got 3 different types of SMARS, quad SMARS. It's never seen this particular one. It has seen another one that I've got on my wall over there. And it was able to detect this one even though it's never seen it before. So that shows to me that the model's working well. So we test the model with the test data. The weight adjustment is done automatically by the algorithm, by the training program, and we keep training until the results are acceptable. And one of the ways we can do that is just by defining how many epochs this will go through. So for this one, I went through 30 epochs to train it. I did one initially just to see, and then after that worked well, I then went for about 30, and that took around, was it 30 minutes to 45 minutes? It's very quick for a mobile device. So again, these slides, just these next 2 or 3, are from that presentation I did on the object detection previously. So I will whiz through this a little bit. If you want more detail on that, go back and watch that video. But so essentially we capture an image. This is how machine learning works. The camera will take that and it pixelates it. It's converting that real thing into a series of RGB values, so red, green and blue, and each of them is between 0 and 255. It will then create a grayscale version of that, because we don't actually need red, green and blue for a lot of image processing. We just need to see the image itself. So turning it into grayscale, so just the value between 0 and 255 will give us the grayscale. And then we essentially split that into a big array. So the neural network doesn't see like we do. It doesn't define areas and shapes and everything. There is literally just pixels, which are values between 0 and 255, and then eventually they become a number between 0 and 1, so they become like a floating point number, and they just represent what that particular value is for each cell in the array. So we convert that to grayscale. It's just simpler to process. We don't need the color information. It doesn't actually add a lot of value in the cases that we're doing. And a lot of the times as well, it will reduce down the image. So we might have captured this as like a HD image. So maybe like 1920 by 1080p, something like that. And it will reduce it down to 300 by 300 pixels. So it's a lot smaller, a lot easier to process. And doesn't take as long to go through. And in fact, one of the ones that we looked at on our previous stream, I think they were actually reduced down to a 28 by 28 image grid, whereas we're working with 300 by 300. So it's a bit more resolution, we get more accuracy, but it takes a bit more power to do that. So as I've said, it treats the image as an array of values. So what we see as colors are actually just values between 0 and 255. So they're very small to store each one of them, just a byte. And then there is the neural network. So there's all these blue things are the neurons. The net is the connections between all those neurons, and they line up in sort of layers. So each layer connects to the next layer, to every node in that layer, and where the connections are, they are the weights. They're the thing that get adjusted by the training algorithm. Hey Wayne, how you doing? So these neural nets, so the neuron receives the input. So initially that's just the pixel value, and it might be a bunch of pixels, not just one per neuron. It might receive 10, for example, per neuron. We then have the weights coming in. Initially they're a value of like a half. And then we multiply the weight by the input values. So we simply do a bit of maths there. You can see these were the grayscale values. They're now multiplied by the weight, 0.5, to give us a bunch of values. We add them all together, and then we have to crunch that down using something called a sigmoid function, which just makes it a value between 0 and 1, because that number is too big for what we need it for. And we looked at what the sigmoid function was in the other video, so I'll not cover that on this one. So the type of neural network that we're using is one that's called MobileNet SSD, so single shot detection. And before, when we were talking about classification of images, localization, identification, that identification and localization of the objects in the scene, think about how you would do that as a programmer. You might scan every single pixel or a block of pixels, maybe like a moving window, to see does it match more or less this object that we're looking for. Now, if you're going to have several objects in a scene, several classes of things, you might have to do that several times and pass through, and that wouldn't be very fast. So the single shot detection essentially just moves through the neural network once, and it's able to detect all classes and all instances of an object in that particular image. So it's very, very fast and very efficient at doing that. So that's you'll see that very commonly if you're using neural networks to do this kind of work. So MobileNet is what we're going to be using today as well. So if you like these videos, remember to give it a like. If you're watching on the video now on Facebook or on YouTube, give me a like, give me a thumbs up, drop me a comment as well. Just let me know what you think about this, if you've used this, if you've got a Jetson Nano or you're thinking about getting one, or if you've used the Raspberry Pi, or if you've used something like an ESP32. They can do an amount of processing, I believe, but I've not tried that myself yet. I do have the, have I brought it with me? The ESP camera, the ESP32 camera, and I'm intending to stream video from that and then run it through the Nvidia neural network to see if it can do that from several wireless cameras. That'll be quite cool. So yes, if you like these videos, give me a thumbs up, a comment, and if you've not subscribed to the channel, what are you doing? Subscribe now. So I do also have, oops, that looks interesting. Let me just, I seem to have disappeared there. Let me just bring myself back in there for a second. I've not adjusted these overlays in some time, so I think the camera must have changed. So if I go up to there I am. Fantastic. It'll do this on the other two as well. So yes, I do a video every single Sunday, 7 o'clock Greenwich Mean Time. I think we're on GMT +1 just for about another month, I think, and then it just reverts back to Greenwich Mean Time. So yes, you know where you live around the world. So let's give this next one. I think it'll do the same thing, but I'll quickly swap that out. So let me just switch the camera back to me. So there we go. I'll show you what this is to do with actually. So yes, check out the website smarsfan.com. That's where I put all the tutorials. I've actually given it a bit of a facelift since I did this little clip here, so I'll probably need to update this call to action as well. But yes, I recently upgraded the capture device I use. I used to use these little HDMI video capture things to bring in the HDMI video from my camera, and I'm now using a proper Elgato HD 60 Plus, I think it's called. So it's a bit more crisp and it can do 60 frames a second. And what was the last one I was going to show you? Again, this is probably needs to be fixed. Let me just do that as well. There I am. Awesome. So yeah, if you want to support the show, you can go to buymeacoffee.com and / Kevin McAleer. You can also download some of the stuff I've got on there. So of the top trump cards that I created in last week's video, quite a few people downloaded them. If you've not grabbed a copy of them yet, head over there to do that, and that can help support the show and pay for some new equipment. So I'm looking to get a new camera for my overhead stuff. So currently the camera that I've got is this camera here. It's not the best camera. It was a cheapish USB camera, and yeah, it's not the best camera in the world. So if you want to help out, support the show, you can do just by going to buymeacoffee.com / Kevin McAleer and just buy me a coffee, and that helps support the show. I think that's the things I wanted to cover off there. So let's get back over to our keynote. It talks about our new video. Yes, we've covered that. Right, training the model. So this is where the magic happens. So we're going to train the model. We can retrain an existing model. And in fact, this is what we did with the mobile SSD net. MobileNet SSD even. We've taken an existing model that's already been trained to detect images like people and cats and pens, and there's quite a few objects that it can detect, and we've essentially added 4 things to that, and then we've retrained it. It doesn't take us long, and you kind of build on that learning that's already taken place there. So we run the SSD train.python script. All these are Python script. There are C versions of this as well in the repository, and we'll have a look at that in a minute as well. So things I found out the hard way. So the labels file simply needs to be called labels.txt, or it doesn't work properly. that must have wasted an hour of my life. I think I called it smars labels or something, or class labels, something like that. And the path where you pass in where the model is shouldn't have any kind of like slash in it. I was getting a bit ahead of myself with there and put in a /, which meant the root directory rather than the current working directory that I was in. Again, that threw me for probably another half an hour. And it takes a long time to capture 1,000 images of each class. So I did skip that and probably only did a couple of hundred. So more images is a better quality of object. And if I tilt these up, they won't work. They're only sort of straight on, or as they were sat on the table. And the training, I was actually surprised how quick this was. So I think 30 epochs, which is like 30 sessions of training, took about between 30 minutes and 45 minutes. It was quite quick to do, which I was impressed with. Okay, so yes, I followed along with the Jetson Nano developer site. They've got a tutorial there that's called Hello AI World. And they've got loads of tutorials on there, some nice YouTube videos, better than this one, explained by the people who've written the software, by Dusty NV, who's a GitHub repository we can see there. And it's built on PyTorch, which is a neural network based on TensorRT as well. And Nvidia have thrown in their own stuff because it's obviously optimized for their hardware. So they take all through all the different steps. We're going to have a bash at this now, but I'm not going to do the entire thing because it does take a long time to do. But I'm just going to show you kind of a flavor of how this actually works. So it's demo time. It's my favorite time. So let me go over to this here, which is, I just wiggle the correct mouse. There we go. So I'm on my Jetson Nano and I've got two windows open here. So let's start off with this window here. So what I'm going to do, I'm just going to run the command, which is camera capture. And I'm simply going to say camera capture, and then video 0 is the USB camera that I've got plugged into this. So I've got a web camera just here. So what I might do is hold various things up and you'll see me just wheel back to them. So if I pick up this here, you can see in real time, that I've got access to these things. So if we want to, capture that auto DIY that's there, what we will do is we'll go over to this window up here. Let me just move my mouse out of the way. This window up here, let me just bring this down a bit. So we are going for detection. And we can say where the data path is going to be, the class labels. I'll just pick the class labels from there, which is in our Python training detection and SSD folder. And then within that, I've got a models folder. In fact, let me just jump back up a folder there. Data folder, because we're creating the data. I've got a SMARS folder, and there we go, labels.txt. So labels.txt means I can now freeze this image here. So if I go to, what am I missing out there? I think it's the detection path. Let me just set that up. So that is okay. Let's choose that folder. There we go. So now I can freeze the frame. So if I'm waving my hand here and then I freeze my frame, it's going to freeze that. I'm waving my hand now and it's not actually showing you anything on there because it's frozen that frame. But now what I can do is I can draw that rectangle around the object that we're interested in detecting. Now you do need to be quite tight with these boundaries. Anything that you do that isn't exactly around the object, or if you draw too many, that's also not helpful. Just remove that one. If you don't, there we go, that's what I'm looking for. So I'm just looking to get that foot and also the head. We want it as tight as possible because we don't want to include any extra noise. That'll just make it not as good detection. So we're going to make sure all the different parts of the thing we're detecting are within that bounding box. It doesn't matter if it overlaps with another one. So if this was like overlapping, I'm just going to unfreeze that now. You can see there now that's sort of slightly obscured. Let me just unfreeze that. You can see that sort of obscuring the auto there. That's fine. We would still do the same thing. We would freeze it and we would draw around what we can see. So the fact that we can still see some little bits there is fine. It doesn't matter that this is being obscured because later images will eradicate that from the neural net. So over time, it'll realize that that's not an important aspect of what makes up an auto DIY object. So if you can see in that little window there, it's not very easy for me to zoom in on this. Let me see if I can actually zoom in. I don't think I can because it's a screen capture. So on this little window here, it says class. So I can drop down there and it's reading that text box, the labels.txt, and I've got auto DIY as a different class there. You can see it's changing the color of the boundary box. So that's purple for the SMARS Mini, but we want auto DIY. And then it's got an X, a Y, a width and a height. So that's just the X position, the Y position, the width and the height. And then we can delete that if it's a mistake. But what we can also do, we're not limited to just doing one object. This scene has got several things in it that we're interested in, so we can actually bring those in as well. So I could draw a rectangle around that one. I can say that that's a SMARS quad. We've got, there we go, that's a SMARS. Yep, a regular SMARS. I'm not differentiating between that and this type of SMARS that's down here. I'm just going to draw one around that. So that's a SMARS, and then we have just at the very bottom there a SMARS Mini. So let's just select that one as well. So you can see that it takes a bit of time to do this, and then once you've done that and you've saved it, you then have to move everything about a bit, give it a slightly different angle, and then do it all again. So you then go back, you freeze the frame, you then sort of draw around each one of these yet again. So it takes ages to do that, and you've got to make a decision as well. So for example, should I do that and include the wires? Are the wires what really makes up that particular robot, that object, or is it actually just that bit there? Because the wires are not something you might see on every single version. You see these other ones haven't got that, but we'll include that there. Just move that out of the way a second. And I'll just bring that sort of in slightly there, and then I'll push that one out just to get that edge on there. And there's also another one here. We could just draw a box around that, and we'll then move on to the next part. So that's there. Okay, so each one of them have been correctly assigned. I don't think this one has here, so that one, is that one there? That needs to be a SMARS Mini, and so on. So once we've done that, we will have to count roughly how many images we've saved. Have we got 1,000 of each type? Have we got them from every single angle? So I've just appended one there. So if I unfreeze that, you know, should we get one that's like that angle? Depending on how we expect this to work. If our robots are never going to see a robot on its side, maybe we don't need to capture that. But just to have total detection and be able to see something from every angle, maybe that's something we should do for this as well. And you can see there it says the current set. So we've got train, we have validate, and we have test. And we can actually merge all the sets together just for speed and have all three the same, but that's not best practice. It's actually best practice to save half of your images for the training, half for the validation, and then another half for maybe a third for the testing. So yeah, data collection, as Hypothetics says, takes the most time-consuming part there. So let's go over to the next thing. So I'm just going to close that window there, which is just going to stop that little Python script running. That's all been done in Python. You can see there, it just says that's shutdown complete. It's been using something called GStreamer to bring in the video, and the video is very, very quick, as we shall see now when we're actually going to run the finished version, and I'll show you the intermediate steps in a second, but I just want to get to the interesting part of the demo here, which is this one, and we'll go through it once we've had a play with this and have a look a bit more detail about what's going on there. Right, so it's going to bring up a window in a second, and it's going to detect all those objects in that scene. And it just takes about 30 seconds for it to fire up. So there we go, everything's looking good. I've typed all the correct things in because I tested it before I went live. And then it's going to bring up the window with all the objects in, with all the bounding boxes around them too. Come on. I knew this would take, was it 24 seconds when I was testing out. There we go. Right. Okay, so you can see there, it hasn't detected the SMARS that's on its side, but the second that I flip it, it's detecting that it's a SMARS correctly. Let's pull some things off this scene. Sorry if the audio's dropping in and out. I'll try and have that just there. I'm going to pull all these away from the scene. And let's just try one thing at a time. So there's our auto DIY. It's nicely detecting that. Doesn't look as confident as you'd expect it to, you know, 71 something %. Let's rotate it round and see how that goes. It's obviously, I've not taken any captures of my hand, so it's guessing my hand is a SMARS, which is interesting. But you can see there, as we rotate this round, it's quite confidently detecting that. There we go. Let's try moving a leg. If we do it at an angle, yep, it's still happy with that. And I haven't recorded any images of at that angle, so that's quite interesting. Let's now drop on a SMARS robot. So it's happily detecting that. 98%, there's loads of SMARS images in there from pretty much every angle. So that's why it's very happily detecting that. I didn't take as many of the SMARS Mini, so put that down there. It is detecting it, and you can see there we can obscure them, and it's confidently detecting them. It's not detecting the auto quite as well there. Let's do that. Yeah, so the second that it goes behind it, it's not quite as confident that there's something there to detect. One of the robots that I didn't include in the image capture was the weatherbot. So I'm going to bring the weatherbot in now. Oops, just destroyed my weatherbot there. So if I bring in weatherbot, it just ignores it. It doesn't understand that that's anything that it should detect, so it completely ignores it from our scene. Let's just move it out of the way. Oops. Similarly, this SMARS quad robot, it's never seen this SMARS quad robot in any of the training, and it's guessing that it's 98% sure that that's a quad robot. So I'm very impressed with its ability to detect that. Again, if we bring in the other one that it has trained on, it's very happy at 98% that that's a quad robot from almost every single angle. I was curious to see as well, if you tilt this up, does it continue to detect it? You can see there, it hasn't got any data to say that that's a quad robot. So it's never detected it from that angle before, but side on, it's very, very confident that it knows what that is. Okay, so let's move that out the way. And then another SMARS robot, it's never seen this one before. So let's see if it detects this as a SMARS. That's got the line sensor module on. And it's still happily detecting that as a SMARS robot, even though we never trained it on that. So it's detecting these objects, these features of it quite confidently. Let's bring in some other SMARS robots. So bring in that one. I think that's a quad. That's interesting. So it's never seen this one before. Oh, it's now detecting that as a... Let's move some of these things out. Maybe it was detecting that one behind it, actually. Let's move that out of the way. So yeah, it's detecting that as a quad because this feature is not something that it's seen before. If we take that off, I bet that it detects it as a SMARS. Nope, it's still detecting that as a quad. It's now detecting it as a SMARS. Now, to be fair, I didn't train it on that, so it has no way of knowing that that particular part was something of a SMARS robot. So you can see how fast this is. This is running very, very fast in real time. Very impressive how quickly it can do that. So, I mean, I'm not saying we could use this in a road traffic situation, but it's certainly good enough for doing real-time object detection for us. Now, if you was watching James Bruton's video, he did something, he had a similar kind of setup, and he detected triangles, squares, and circles, and then he had his robot drive towards that, and he was using the position of the object. He'd taken that out using the Python script and edited that. So where the X and Y is, he could move the robot left or right to make that object more centered. And when it was centered, he would then drive towards it so that the width increased. And when that got to a certain size, it would then turn and then try and find the next object. And he had it sort of going in a circle, detecting the circle, the triangle, and the square, round and round and round. So I was thinking, we could do something like that, bringing in our... Where's my robot gone? This one has the wireless charger on the bottom, so we could have a symbol that's like power, maybe two well, maybe not two zigzags, that's probably not very good from a historic point of view. Maybe some kind of like power symbol, and it can detect that, and it can drive towards that, and then actually, as it gets closer, it could slow down and be a bit more accurate and hop onto its little charging bay. So that would be a really cool thing to do, as well as just being able to detect its friends. They could all swarm together and find each other and run away from enemy robots or something. I don't know. So yes, I found this a really, really fun thing to do. So let's get back over to the... Nvidia, and let's just stop this for a second. And let me show you how we go about running the training program. So I've just got this connected by HDMI input, so I'm not doing any kind of screen share thing. It's just, this is why that's so fast. I did look at using VNC, but it was very, very slow, and you wouldn't have got the full flavor of just how fast this is at running. Okay, so let me exit, in fact, this, and I shall take you through one step at a time how we do this. So let's just type exit. Okay, so the first thing I did was I went to GitHub and I cloned the repository, the Jetson Inference repository. And once I've got that on my machine, I went into this folder here, and I think there is a couple of scripts that are in there. And one of the first scripts is Docker. So let's just cd into Docker. Apologies that this is so small. I wonder if there's anything we can do to... There we go, zoom in. Let's zoom in a bit, and we can all see what's going on then a bit easier. Okay, do another one or two. Okay, so there is a folder that's called Docker, and inside that Docker folder there is a bunch of scripts. So there's a build script, pull, push, run, and tag. And all I've done is run the run script. So if I just jump back, type in docker /run.sh, Docker, not docket. If you've not come across Docker before, Docker is a containerization technology. So think about container ships, got lots of containers on it, and Docker allows you to run lots of different pieces of software in separation within their own container, and you can very quickly download containers, update them, distribute them. You can do all kinds of clever stuff with them. Let me just type my password in properly here. I changed it from the very simple password. Good grief. There we go. Right, so we're now running that Docker instance. So the container there you can see is called Dusty NV, Jetson Inference, and then R32 6.1. And Hypotic says, I do not grok Docker. The container is that, the volume is a folder, which is that GitHub folder that I downloaded, but it actually has that as like the root of that particular container. So it can't see anything outside of that. It's just brought it in. And then the other thing that it's brought in is the device that's called Video Zero, which is the web camera that I've used. Now I have actually got the Raspberry Pi MCSI camera on there, but that isn't working at the moment for some reason, so I'm not sure what I'm doing wrong there, but that's not working. So I plugged in a USB camera, that works fine, so we're using that for now. So now that I'm in that Docker instance, we can see a bunch of folders there, so I'm just going to go into the build folder. Let's have a look what's in there. There's a download models. You can run that, and that will tell you what. Let's run it and see actually. So if we just download models, you can see there's a whole bunch of different models. GoogleNet's similar to MobileNet, ResNet, AlexNet, Inception, and there's different ones for different purposes. So these object detection ones, as you would expect, are very good at detecting objects. The Inception one, which is huge, has got all kinds of objects in there, all kinds of office and household objects. PedNet, MultiPed, FaceNet, DetectNet. You can see there dog, bottle, chair, airplane, mono depth, pose estimation. So if you've got, think about a Xbox 360 or Xbox One, show my age with a 360, and that had the Kinect sensor on it, and it could detect kind of what body pose you're in, what your limbs were. The pose estimation does that. So it can detect all different parts of your body and therefore what position they're in, using that segmentation type stuff. Then there's semantic segmentation, which is about cityscape, so that's good for driving down a road and detecting street signs and pedestrians and all that kind of stuff very accurately. So there's a whole bunch of them. Got some legacy ones in there as well, image processing, and that's it. So if you click on any of them, you can have this script download them for you. So I had to play around with the fruits one just to get familiar with it. So then if we go into the ARC64, which is the architecture of this, we then go into the binaries folder, and then there's a whole bunch of scripts in there. So camera capture is what we used in that window up there. So when I ran that up there, that was actually camera capture, and then the parameter that I was using was just simply /dev/video0, and video0 is the webcam. DetectNet is the next program that we ran. That's the one that we ran in this window. That it took that model that we'd built and then it ran that particular model. So DetectNet is what we use there. And then there's a few other pieces on there that we probably don't need to look at. So what we're going to do is come out of that. Oops. Maybe if I'm in the correct window. Let's just back out of that. Get back down to the first folder. And then we're going to go into the Python folder now. So in this Python folder, there is a training folder. So let's go into the training folder. Then it's got classification, detection, and segmentation. We're going to go into the detection folder. Then there's the SSD model. So we're going to go into the SSD folder. And then finally in here, there is a couple of scripts that we use to build and then test our model. So there's 3 folders that we're interested in. There's data, models, and vision. So in the data folder, that's where I stored my SMARS model. So I created a folder that's just called SMARS. And then in there, there is annotations, image sets, and JPEG images. And then there's that labels.txt, let's get rid of that other one, class. We don't need that one. So if we just have a look what's in labels.txt, I just run cat to catalog that. We can see in there it simply says SMARS, Quad SMARS, Auto DIY, and SMARS Mini. That's all there is in that particular file. So if we now go into JPEG images, we can see there's a whole load of images. And in fact, we can actually open that folder up. Which one is it for the folder? I'm rubbish at using Ubuntu. So, do you know, I can't even remember how you open up a folder in this thing. File thingy, there it was. Let's just go for that. I don't know if that's the right one. File manager, it looks good enough for me. Okay, so if we go back to where we were looking there, so Jetson Inference, we're in Python, then we're in the training folder, then we was in the detection, then the SSD, then the data folder, and then SMARS, and then JPEG images. So let's have a look at one of these. There we go. Awesome picture of some SMARS robots just hanging about there. So you could see what I did there. I just took a picture and then moved to another, just moved them around a bit, took another picture and so on. But using that software, which was the camera capture software, it creates for each one of those images an annotations file. So if we have a look at this particular XML file here, let me just move that over a bit there. You can see it says annotations, file is the file name there. The folder is SMARS, the source is SMARS, the annotation name is custom, the image is custom, the size is 1280, height is 720, so it's 720p-ish. The depth is 3, so RGB, and there's no segmentation information in there. So that one I actually hadn't classified. So let's just pick one a bit further down that has got a classification in it. So this one, where are we? On the database SMARS. I was looking for the actual name. Let's try another one randomly down here. There we go, that's better. So this has got a few different objects in it. So there's an object that's called SMARS. It hasn't got a pose, so that's unspecified. And then the X, Y, X max and Y max. So the coordinates of the window, wherever that is within that object, within that image, in fact, for that object is specified there. So this is what it generates, which is just raw data. Once we've got all those things done, we can just jump back out of there. And let's jump back again. Okay, so then we've got the train SSD. So that's what we would actually use. So if I just do Python, Python version, we can see we're on version 3.69. So we're not massively behind the times on that one. What are we on now? 3.9 is it for Python? So if we now do Python and then train SSD, .py. Now it does need to know lots of information. You can't just run that. It needs to know the model directory. So that is smars. Even it's model smars. It needs to know the labels file. Hey Adam. So labels equals label. So that's under model. In fact, that's under data. And that's under smars. And that's under labels.text. What else does it need to know? The data. I think, is that data? I can't remember off the top of my head what this one is, but you need to specify where all those images are. So again, that's under data/smars. Let's just try that and see what happens. I might have missed something else out there. It will tell me if there's an error. It definitely tells you if there's an error. It's horrible. It takes it a couple of minutes for it to sort of get started. Yes, I've missed out. It doesn't recognize labels equals. So is it label singular? Let's just try that. I'll give up if that doesn't work because it gets really, really complicated. But there's a whole bunch you can see there. Data sets. What else is the base directory, scheduler, epochs? Yeah, we've not specified what the epochs are. So that's where it's best to go to, which we will do now actually. Let me load up GitHub and I'll show you how we get more information about this. So if I just go to there, then I can share my screen. There we go. So Dustin Franklin is the person who created this repository for Nvidia, and in there this Jetson inference is where all the good stuff lives. So they've got all kinds of detail there: image classification, object detection, semantic segmentation. There's a better view of it there. You can see right around each object it's entirely coloured a particular thing. You can see the street signs, the trees, they're all separated, segmented like so. We've got pose estimation, got some people there, the limbs, which way up they are. Really cool stuff like that. And simply what I did was just went through one of these how to set up your Jetson, and they've got all kinds of, you can build it from, you can use your Docker container, which is what I did. And you just type in that 3 commands. So we just clone the repository, which is this repository we're looking at now. We go into the folder and then we just run the docker command run, and it will grab everything it needs, set everything up, and then you're good to go. It then talks you through how to do all the other steps, such as training your model. Let's see if we can find the bit on training. There we go. So it talks about transferred learning. So the fact that we run this through other objects before, it already knows how to detect. I say it knows, the functions have been trained, have been tweaked to the extent where they accept more information a lot easier. So we don't have to bother with PyTorch. That's already installed by default whenever we do anything, so we don't need to mess about with that. And what else has it got on there? I'm just trying to see if there was a, in fact there it was, retraining your SSD MobileNet. So the command that we are looking for, the droids we are looking for, is around about here somewhere. There we go. So data, model, batch size, and epochs. Right, I'm going to keep that on one screen there, and then I'm going to flick back to let me see there. Now let me just see if I can get this correct. So so instead of it being model directory, we don't need any of that. We just need to say data equals data/smars. We then say the model directory, so that was in there, model dir equals models smars. Helps if you type everything correctly. And then batch size, so this is how many images it processes at a time. Now I'm only on the 2 gig version of the Jetson Nano, and I stick to a batch size of 2, so 2 files at once. And then the epoch is how many sessions of training it's going to run. So this is going to be, let's just do 1 for now. Now if I've typed everything correctly there, what's it not happy with? What have I typed wrong there? Models, model directory. That looks correct. There's 2 dashes in there, that's why that's not happy. So let me just go back to that. And then run it again. I just wanted to get to the point where you can see that it's doing stuff right. It doesn't know what the labels are, that means. So let's just tell it. Where's the label thing? Is it labels equals data smells labels.text. I'll give up if that doesn't work. You can have a play with it. Yep, it's not happy with that labels argument. I can't remember if it's label or label file or label. I could be here all day without knowing that what that is. Anyway, so I can jump back to this other screen and show you on here. So what it said, so this is what you would see. You would see a timestamp, it would say epoch 0, and it would give a bunch of steps. I think there's about 70 steps when I was doing this. And then it would tell you what the loss is. So it would start out as a really high number, and then that would come down, and you want that number to really be under 1. Ideally like 0.1 blah blah blah. So the smallest possible number, because that means you've got a really well trained network. After it's done that, it will then save the model out to something like this. So it'll give it a model name. It'll say MB for MobileNet SSD for that single shot detection, epoch, which is the epoch number. It'll tell you what the loss was, and then it'll have this .pth as the file extension. And the more epochs you do, it'll do 1 for each epoch. And then when you try and convert that, so we need to convert the model to be an open neural network exchange file. So we just run this ONNX export. We pointed at the particular model directory. In theory, that's what you should do. I had to hack around with this a little bit, and it will look through each one of the epochs and find one with the lowest loss number, because it might not be the last one. You can actually overtrain these models and it will actually get worse at detecting things. So there is an art to sort of specifying how many you want to run there. And it could be between 30 and 300, depends just how much time you're willing to throw at this. Okay, so that's what we can do. There is a whole bunch of other test ones we can run in there. There's like fruit, there's airplanes, there's toys, there's all kind of stuff. But I was really keen to detect my own objects to see just how easy this is to do. And it's easy, it's just time consuming and a bit fiddly. I've said it's for intermediate. I don't think this is an expert skill to do this, because you are just following kind of a script from someone. So it is quite straightforward to do that. So that's why I've sort of said it's an intermediate kind of skill. Okay, so let's have a look at some of the comments we've got through here. I've not been ignoring your promise. So let's have a see what people have been talking about on the chat. So, and also let me just throw up the overlays, because I've got a few overlays there that I was missing off. Okay, right. So we have quite a few people, good grief, on the stream today. We've got 12 people on here. So Carlos, hey Carlos, how are you doing? Nice to have you on the stream today. And Richard was saying every day is like Christmas for me. Yes, so I bought a whole bunch of things I want to show you. So one of the first ones was, I was talking with Adam on last week's show about these little M5 stamps, the Pico stamps. It's an ESP32 in a little form factor. So I've just been having a play with that. I've not actually done anything with it yet, but I had ordered that and that did come in the post. And I've got some other things I wanted to show as well. So one of the shows I would like to do soon is one with infrared. I'm using infrared to control. This one comes with a little remote control. To control the robot, so we can sort of send and receive data to it and have it move about. I mean, I think this one is just to send only. I don't think you can send and receive with that. And also in the small robots group, somebody was having an issue with some NRF modules. So I bought a pack of stuff. Let me just show you what's in here. So in here we have, I don't know if you can see that, if I can get that on there. So there's a module in there, and there's got an antenna as well. And then these also come with a little transmitter module, receiver module that plugs into. And then there is also, where is it? a whole bunch of Arduino Nanos as well. So there's essentially 2 Arduino Nanos and 2 sets of senders and receivers. So I bought a bunch of them. I'm going to have a play with that and see if we can get a remote control SMARS using NRF as well. So that's why it's like Christmas every day for me. I think they were the things I was going to show you. I don't think there's any more just yet, although there probably is. I'm getting so much stuff every day. Hey D Johnson, how you doing? So Hypotics was saying I've got I have on each feather RP2040 and a Teensy4 running MicroPython 1.16. And I've seen one of those things running on CircuitPython. Awesome. So I do believe you can use TinyML on Raspberry Pi Picos and the ESP32s. I've got a Teensy as well. I was looking at that before, actually. I think it's a version 3. I digress. I've just found my... there we go. There's the Teen... No, it's not. I get distracted easily. It's in there somewhere. But I did find the camera, the ESP32 camera. So this thing, it's not particularly easy to plug into. You do need one of these FTDI things to plug it in. But this camera here, it's got an SD card on it as well, and it's just an ESP32 chip. You can just see it on the back there. And you can stream apparently from these. So I was thinking we could stream from this video camera. This could be, you know, mounted onto the top of a SMARS robot, something like that. I'm sure Kev Thomas has done something like this already. This can be driving about, streaming its video, but then you could use the power of another machine, even like a desktop computer, to process that through a neural network and do image detection and whatnot. So Hypotics was also saying that use different backgrounds can also help during the capturing, because that noise there, you do want that noise to be filtered out, and that's a good way to do it, is just have a kind of a busy background as well. So a question for later regarding training: would putting an object on a turntable to change the angle help at all? It would. You would certainly get many angles by doing that. I do actually have a turntable just behind that white thing. Sometimes you can see it. Let's move that out of the way. There's a whole bunch of stuff just sat on it there. It's that white thing that's just there. That is the turntable I have. So that would certainly help, but you do want to get it from as many angles as possible. It might be a bit too uniform if the thing's, you know, pivoting round there. You want it to be sort of a bit closer, a bit further away, because that will, the closer an object gets, the more distorted it gets on the camera, and the further away it gets, you know, you can get that perspective effect on it. So you do want these things from many different angles, just so that the network can take that into account. Possibly even not using the same camera, though it probably would make sense to train it on the camera that you're going to be using to detect stuff on there. So yeah, I would say turntables certainly make it easier as you capture it. So hey Wayne, how's it going? And Hypothesis says it's not actually bad to have images where part is covered. The A will get smarter that way. Absolutely. So it'll then learn to detect what is and isn't part of the object. So it's quite good to do that. Collecting data is the most time-consuming part of deep learning. Amen to that, I would say. So the data is most important part of the process. If you have garbage in, you'll get garbage out. You know, I was even thinking about including that exact phrase on one of the slides. I was thinking, you know, quality in, quality out. And the Arcanis87 says that is so cool. It is so cool. Honestly, I have so much fun playing with this. So yes, be sure to take some images of them falling down. Yes, so if it's tipped over, we want that to be included in there as well, and from every angle too. So you just have to spend a whole load of time doing this. So it needs much more data. And in fact, so one of the projects I've got on the back burner that this will be perfect for is TwitcherPy. So it's on my GitHub repository. And the idea was, if you've got a bird table, you've got a Raspberry Pi Zero pointing at that, you can detect that there is birds on a bird table, and you can classify them as being different types of bird. And I went to the extent of downloading the top 20 birds from the RSPCA, Royal Society for Protection of Birds, and you know, what are the most common English birds that you'll see in a garden, and then have it classify each of them. And I didn't have a bird table at the time or a camera set up outside to take these pictures, so I simply went on the web and downloaded 100 of each type of bird, and there was 20 birds, so it was like 2,000 and odd pictures, is it? Is that maths right? And yeah, this took a very long time to do, drawing the rectangles rather than classifying them and so on. And then what worked well was if you gave it a picture of a bird that was kind of like this from the side, from the front, doing some elaborate thing, it would work fine. But if the back side of it, no one takes pictures of the back sides of birds. So, of the avian variety, certainly. So because of that, it only works when the birds are front on or side on, or sort of taking off, something like that. So that's one of the things I was thinking about maybe working on a bit further, and using the sort of knowledge I've got from this as well. I know how I could do that. I was actually thinking about combining it to make it a bit more automatic. So if I had a presence sensor, like using one of the infrared things I've got from the one of the kits, which is on just there actually. That's the Pico starter kit. In there is an infrared detector, a motion sensor. That's the one word I'm looking for. A motion sensor. So if I had a motion sensor set up to trigger to take some pictures, I could do half the work, which is taking pictures of the bird table while there are birds on it, and then I'd only then have to go through it and draw rectangles around a bunch of them. So I was thinking about having some logic. If it triggers it, it would take a picture, but then wait for 2 or 3 minutes before it does it again. So that's one of the things I was thinking about there. So hey Tom, how's it going? So Hypotic says I do not grok Docker. Grok is a Unix command, isn't it, for finding things. So Adam was saying good evening. How are you doing, Adam? So you prefer the Mate window manager instead of the stock one. I hate that stock one. I've got to say, I much prefer the whatever they use on the Raspberry Pi. I quite like that one. So is this on George? George. Is that what we've called our AI? I don't know. Have we given this a name? I know we've got Alf, which is my other AI, which we've been working on. Maybe this should be called George from now on. I think you've just named it there, Adam. I'm going to have to rewatch this later because I'm getting distracted. I get distracted and I'm the one doing the stream, so yeah. I'll watch it back too, I think, at the end. And I need to transfer my Pi camera to the Jetson Nano. Right, so I have done this. Let me just set this camera up so I can show you what's going on here. I've got a really messy desk as well. I've got to apologise. Right, so if I go for that, there we go. So this is my Smars XXL, and I've just stuck it on there for now. It can actually go behind it in a little hole there, but for now I've just stuck it on the front. It's configured the right way round, but for the life of me, I can't get this to actually work. So I don't know what I'm doing wrong there. Apparently it should just pull that in, but it's not working. That is a real pitter to do though. Pitter? Is this some kind of gag that I'm not getting there? Those not the droids you're looking for, absolutely not. So I keep losing sync with the stream. I'm going to jump out this and watch later. So you say out of sync that you're not following the conversational thread, or is it stuttering a bit? Because I do make sure that I'm it looks healthy. I do check on the stats and make sure I'm connected by not Wi-Fi before I do these. So does it work with other sources, e.g. audio? Could you get it to detect bird calls? Absolutely. So yeah, you don't have to just do image detection. There's all kinds of audio detection. In fact, if you think about I've got one just there actually. I've got an Amazon one just there. That's just pure speech recognition. So there's a whole load of technology around wake words. I thought that was just as simple as running sound through a speech recognition engine, but wake words are like a separate thing in themselves because they've got to listen to all kind of background noise and then fire off the speech recognition. So yeah, you could definitely do that. I've not looked at any of them yet, and the Jetson Nano, even though it's we think of it being graphical, the GPU that it's got there is just very good at crunching numbers very, very quickly. So it doesn't matter that it's a graphics processor, it can do audio just as quick. So still waiting on those prototype PCBs, and the ESP cam has heating issues. Right, so mine has got that. Mine gets really hot. This probably was an early version. I might have ordered some other ones before this stream. I can't remember. I think I might have ordered a couple new ones. So yeah, garbage in, garbage out. Definitely a recognised phrase. RSPB. Is that what I said? Did I say RBP? Oh, I have no idea. Royal Society for the protection of birds, not prevention of birds. That's a different society. Oh, George Jetson, of course. That's why he's called George. Yes, George Jetson. I follow you now. I follow you now. Yep. So it's tiny compared to my flat. Right, this is really not tiny. This is really bad. I've just got a mound of stuff here that I really don't want to show you too much more of. But yeah, there's just a whole load of bits that just needs tidying up and stuff putting away. I mean, there's a failed version of that SMARS XXL. I blocked out in the 3D model, like this is the size of the Jetson Nano, and I actually left that 3D block in the design, so when I started printing I was like, why is it printing that out? So yeah, that was kind of stupid. Alright, so I said RSPCA, Royal Society for the Prevention of Cruelty to Animals. Ah yes, it's RSPB, Protection of Birds. Yep. So that's called the live adrenaline monster. I think when you're presenting and stuff, a lot of stuff just falls out of your head. So that's to do with that. It happens. Cool. Okay, so I hope you enjoyed this this video today and how we can detect objects on there. I'm just going to jump back to that and have a little play with that again. If I can remember which button it is that button there. And if I just wiggle my mouse and get rid of the screensaver, we can hopefully just page up to get to the right one, which should run. In fact, I'm going to have to jump back to... Oh, we want to be in the detection folder. We want to be in SSD. And then we want to find the command which just runs it, which is the detect_net one. So let me just find that. I've clearly typed a lot of stuff in since then. There we go. We're not far off it now. That was what we were talking about first. Oh, it's because I exited it, didn't it? Oh, that's why. So detect_net. What is the thing for that? Is it model? Do you know what? I can't remember what the whole command is there. I need to write a script so I can just type go and it'll do it. Because I'll forget what it is. And you don't want to see me just badly typing in commands for the next half an hour. So I was just going to run that and have another play with it, but that's fine. You've seen it. That's it. If you don't make mistakes, it's not alive. Absolutely. This isn't Blue Peter. I prepared one. Here's one I prepared earlier. Blue Peter was a kids program from the 80s, and I think they still have it on actually on the BBC. And they always used to have this thing where they would have this really complicated build, and then they would just pull out from under the desk. Here's one I prepared earlier, and it's like, yeah, you would like the production assistants. That's way production values are way too high than is achievable by a child with some cardboard. Can it deal with multiple inputs, by the way? So 3 streams from 3 different sources. Yes, it can. I think the chip's really designed for just one lot of that, and certainly the memory. That 2 gig of memory gets used up pretty quick. You get these low memory warnings, in fact. But yeah, you can do that. And it doesn't have to be a local camera either. You can use that, is it RTSP, to bring the video across from something else, which is why I was thinking about that ESP camera, wherever that's disappeared to. You know, I was thinking about bringing, there it is, bringing across video from that, running it through the Nvidia Jetson, and you know, we can detect it from a humble SMARS that doesn't, because this just needs 5 volts, so this can just literally be stuck onto another robot. It's broadcasting through its Wi-Fi signal, so there's no processing going on here. It's just sending out raw video, and therefore we could then bring that in, process it, and then have that processor tell the robot what to do, like go forwards, go backwards, and so on. So have you already tried the neural network directly on microcontroller with MicroPython? So I've not yet, Tom. I have been looking through to try and find a good example of where that's really practicable. I know the Raspberry Pi Pico has not got a lot of RAM. It's got like, was it 256, maybe 300 and something K of RAM. It's tiny. So you have to crunch those MobileNets down even further. I think you have to make them like an 8-bit version so that it can it's really lightweight. I have seen an example where somebody's they've got a touch screen, like an SPI touch screen, and you can scribble like a letter 3, for example, and then it will detect that that's a 3 using a common MobileNet for detecting characters, and there's only about 26 characters for it to guess, so it's not a massive load on there. and I don't believe it's too slow either. It is okay at doing that. So yeah, I'm looking for a good example. If you can find one, just drop me a message and I'll look into that. I'm definitely looking into seeing how we could expand upon this and what else we could do with it. Which is saying have two smiles looking for each other. Exactly, I was thinking like maybe them chasing each other but using image recognition. So maybe they could have a little symbol on the back, or maybe we could just get them to detect different parts of the robot. So you can detect that that's the back of a SMARS rather than the front of a SMARS. So we could certainly do that as well. Do you see my message about the meaning of PITA? I probably missed that actually. Let me just scroll back. I don't know what you said about that. I saw you said a pun, but I missed what the meaning of that is. So I didn't see that come up on the stream. Tom says that's why I use ESPs. Absolutely, because they got loads more. They're a bit faster and they got loads memory, and they got the Wi-Fi as well. So yeah, I'm definitely sold on them. Cool. Okay, so I think that's everything I wanted to cover off on the show. I don't think there was anything else I was going to cover off, and we have gone a little bit over there. YouTube probably blocked it. It probably did. Yeah, you don't want to get yourself banned on YouTube. That wouldn't be fun at all. So I don't know. I can't see that in there. Got you. Yep. Yep. I have to be careful as well what I put on screen, because if it detects that and it decides that that's like foul language or something, I can get like a takedown strike on that. So that's fine. Cool. Okay, so thanks for joining me on that one. I hope you enjoyed it as much as I did. Let's see where else this takes us. This was just my first introduction to Jetson and using the AI stuff that's on there, the deep learning. Really interested what your thoughts are, where we should take this, what we should do, how we should build it into our small robots, and bring them to life and make them more interesting. So I shall see you next time. Hopefully we'll do a midweek video on maybe one of these projects. If not, I shall see you for the stream on Sunday next time. Thanks everybody for watching. Bye for now.